This is the National Instruments MyDAQ device that we're going to be using in this course. Although it's small, it has a lot of useful features that can help us to mimic and emulate a lot of the things that we would normally have to do in the lab. I'm going to give you a quick run through of the different features and the connectivity that it has with it, as well as some of the software uses for the National Instruments MyDAQ system. So if we look at this, we have a sort of schematic diagram of the different functions that it has. If I look at the top right here, this is the USB connector. So this is where I would plug my device into my computer, and we have a nice blue light that will turn on when it is connected and powered. If we turn the device, up on its other end, we see that we have connections that look a lot like multimeter connections. And that's exactly what this is for. We have connection ports so that we can measure voltages, resistances, and diodes, as well as the ports for the current. The MyDAQ system comes with test leads, and we can connect those test leads just like we would for a multimeter. So if we want to, we're going to place our black lead in the common, and depending upon if we want to measure voltage and continuity or current, we would place our other lead in the appropriate slot. Okay. And there's built-in software that we can use with National Instruments to make this device act basically like a digital multimeter that we would use in the lab. Now, if we look at the other side, in addition to multimeter functionality, it also has the ability to provide different types of outputs. So if I bring this up on its side and turn it around so that we can read the labels, we have audio inputs and audio outputs. So audio signals are just voltage and current signals. So we can measure those voltage signals as well as output different audio signals with this device. We also have a positive 15 volt and a negative 15 volt power supply with respect to ground. Also, we can using software, we can control up to 2 different channels of analog outputs. So we can make different types of functions like sine waves, triangle waves, and or different DC offset levels. We can also measure, in addition to the voltages that we can measure with the multimeter, we also have a place right here where we can measure 2 additional voltages with our high side and our low side. And there's a lot of capability for digital inputs and outputs. Digital signals are 0 to 5 volt signals. They're either 0 volts or about 5 volts, which signifies an on state or an off state. In an analog circuits course, which is what this course is, we will be mostly using the analog inputs, analog outputs, as well as the multimeter functionality. Now I'm going to plug my National Instruments device into my computer using the appropriate USB cable. And we just heard the sound that said that my computer recognized the device, and I also get my nice blue light saying that it's turned on. So what I'm going to do now is I'm going to switch to a software view and show you some of the software that comes with the MyDAQ that you can use. On your computer, you can find the MyDAQ software by looking for the National Instruments, or NI Elvis, ELVIS MX instrument launcher. If you start that up, what you should see are a number of different types of instrument applications that you can use. And for our purposes, we're not going to be using a lot of these, although we will talk about some of these things like function generators, oscilloscopes, and you will be using an oscilloscope in the lab. So there are some of these that we will use, but some like the octave analyzer and dynamic signal analyzer we will not be using. Probably the very first thing that you should become familiar with is the digital multimeter application. So if we just click on that, it will launch the digital multimeter application. And we see that this looks a lot like the front panel of a multimeter. So on the device, you can connect your appropriate leads, your test leads, and the appropriate jacks, and then you can select what you want to measure. We can measure DC voltage, AC voltage, DC current, AC current, resistance, capacitance, inductance, and diodes, as well as use this as a continuity tester. Now there are a couple of different things that you can do. You can specify the range that you think you're going to measure. What this will allow you to do is make measurements a little bit faster. It will update more quickly. So you can say, what is the maximum voltage? Are you going to be measuring something that's 10 volts? You would want to specify your range to like the 20 volt range. This is going to affect the accuracy of the device. It's a little more slow. You can also have the device auto range, and it will try to find the best range to use for the voltage that it's measuring, but it's going to take it a little bit longer to establish that measurement. So it's up to you. If we come down here to instrument control, you're going to be using the NI MyDAQ that shows up. If you have, for some reason, if you have a bunch of National Instruments devices connected, you may see a list of different devices that you could use. But if this is your first foray into using data acquisition equipment and the National Instruments equipment, I'm guessing that you'll only have that as the only selection. And then you can do acquisition mode. You can tell it to run continuously or run once. Let's set it to run continuously. So when I push the run button, right now it's going to just act like a voltmeter. What I will do here is I will configure the leads in my MyDAQ to be like a voltmeter, and I will use these leads. What I'm going to do is I'm going to flip this up on its side, and I'm going to measure the potential difference between the positive 15 volt output terminal, which if this ever focuses, it will show you. There we go. Now that it's focused, I'm going to measure the potential difference between the positive 15 volt output. So I'm going to put my high side lead there, and I'm going to also connect the low side of the lead to the analog ground output. All right, so I'm going to measure the potential difference with my voltmeter, and hopefully that will read 15 volts after I get this properly connected. So between those two pins right there, going back to my multimeter, I see that if I maintain a good connection there, it's going to read positive 15 volts between for the output supply. If I move my lead to measure the negative supply and maintain a good connection there, it should measure negative 15 volts. And I can also do the same thing. I can configure the leads as I would for a multimeter and measure current. The other application that is of interest with the NI Elvis system right now, or the NI MyDAQ system, excuse me, is we may want to use the DC level button, or the DC level application. And what this does is this allows us to set different levels for the analog output value. So here again, we have it's a different application, and it can run at the same time that other applications are running, like the digital multimeter. So here I can set the DC level output for my device, and I have two different possible channels, the analog output channel 0 and the analog output channel 1, that I can generate an output voltage for. So I'm going to select A01, analog output 1, and I'm going to go ahead and set that level to 1 volt. When I say start, well, it gives me an indication that it should be outputting 1 volt to the analog output channel. So now what I'm going to do is, now that my digital multimeter is also running, I am going to come over to my analog output pins on the National Instruments device and measure them and check and see if that is true. So my analog output channel 1 is right here on the MyDAQ device once it focuses. All right, and the output voltage should be with respect to the analog ground, which is this terminal right here. So I'm going to measure that potential difference using the multimeter setting. And since I have set it to 1 volt, I'm going to hope that we get a 1 volt reading out of the multimeter, and indeed we do. And I could change that level on my DC setting to another value. Let's set it to 2 volts, and I will use my multimeter again to read it. And between those two pins, it looks like we are measuring between 1.9 and 2.1 volts, but that's because my range is really high. I'm going to set that down to a lower range so that we have more accuracy on our reading. There we go, and now it's nice and stable at 2 volts. So these are just two simple programs that we can use. In addition to this, the National Instruments device is compatible with LabVIEW, and we can build much more complicated instruments if necessary for a particular application. So in one of your labs, you're going to be building a simple instrument using LabVIEW programming so that you can measure current and voltage simultaneously to generate current and voltage curves. Finally, I should point out that with the LabVIEW device, or with the National Instruments device, there comes this terminal strip, and what this is meant to do is slide over the pins of the different analog and digital outputs so that you can access those, and you can easily put a wire into these terminals and screw that wire down, so you have easy access to readily connect your MyDAQ inputs and outputs, at least on this side of the device, to a breadboard circuit.